7 is on inverse functions. So an inverse function, it says it's the function that results from interchanging the inputs, the x values, with the y values. And the inverse of f of x is denoted by f. Do you guys remember? F to the negative 1 of x. Perfect. Okay. So f inverse of x is how we read that. So what happens is basically if we have a function and we reflect it over the line y equals x, we get its inverse function. So any point that we have, like if I have 1, 10, on the inverse function I'm going to have 10, 1. I don't know why that random 1, 10 is hanging off. We'll just get rid of that 1, 10. All right. Yeah.
So you don't switch, so would it be like negative 1, negative 10?
Nope, you don't make them like opposite or anything. You just switch the two values. Okay. So your x becomes your y becomes your x. All right, so number 1, so it says assume f is a 1-to-1 function. So it says let f of 0 equal negative 2, f of 1 equals 7, and f of 2 equals 5. Okay, so what points are these for f? We have 0, negative 2, we have 1, 7, and we have 2, 5. Do you guys see that? So for f inverse, we should have the opposite points. We should be able to switch them. So instead of having 0, negative 2, I'm going to have negative 2, 0. 7, 1, and 5, 2. So that's what this is saying. It's saying, what's f inverse of 7? So in the inverse function, when I plug in 7 for the x value, I get 1. What's f inverse of 5? 2. And what's f inverse of negative 2? 0. Does that make sense? Okay, so we have some blanks to fill in. So it says let f be a function. If a comma b is a point on the graph of f, then b comma a is a point on the graph of its inverse. The graph of the inverse of f is a reflection of the graph of f across the line y equals x. Okay. And then we have a test to see if something is invertible, I guess is the word. Okay, so if we're able to take the inverse of something so that it is a function in the end, right? You guys all remember what functions are?
Yeah.
Functions pass what test? The vertical line test. If we want to switch all of our x and y values around, and if we want to be able to say that the new thing, the inverse, is a function, we want the original thing to pass the horizontal line test. So it's kind of confusing, but it's because we're switching all the x's and y's. So a one-to-one function is going to be a function in which each y value corresponds to exactly one x value. So something like this is not a one-to-one function. We write it like this, 1, 2, 1, 1 dash 1. Because I would have a point, like maybe I have 4, 2, but I also have 4, negative 2. Okay, that's not one-to-one. Oh, what am I talking about? It is one-to-one. Hang on. I was talking about the, let me draw it the other way. I'm confusing myself. I was doing the inverse already. Okay, so it's not one-to-one if we have like a parabola, because this would be like 2, 4. Oh, geez. 2, 4, and negative 2, 4. Okay, this is not what we call one-to-one because every x value, or every y value needs to correspond to exactly one x value. So see how we have a y value of 4? There's 2 different x values that go with it. So I have 2, 4, but I also have negative 2, 4. So if you flip it over and you switch all of your x and y values, you get that first thing I graphed. Is that a function, the first thing I graphed?
No.
No, it was a parabola on its side. It's not a function. It doesn't pass the vertical line test. So do you guys see how the horizontal line test and vertical line test kind of work together? So this doesn't pass the horizontal line test. So it fails that horizontal line test, which means that when I find its inverse, when I switch all of the x and y points, all of them, all the x's become y's, all the y's become x's, it isn't a function. Okay, that's what we're saying. Okay, so a horizontal line test, it says if a horizontal line crosses the graph of a function f at more than one point, then the inverse is not a function. In other words, the original function is not one-to-one. So what happens when you do that? Let's say you had y equals x squared. That's what that function is that I drew, right? The parabola. And I switch my x and y's. And I try to solve for it. Zach, you with me? So if I take the square root, what happens? Square root, plus or minus, right? So I get y equals plus or minus the square root of x. That is two separate functions. It's not a single function. When you get the inverse, it's two separate functions, okay? So that was what was bad. Oh man, I just ruined the surprise there. All right, so are the following functions 1-to-1? So if I have y equals x squared, is it 1-to-1? No. How about 1/2 x cubed? So it's going to look like x cubed, only it's going to be flattened out a little bit. It's going to be a little fat. Yes, it passes that horizontal line test, right? So you can run all these horizontal line through, and they only touch in one point. All right, 2x minus 5. Yep. So you can find the inverse of number 2 and 3, but the inverse for number 1 was two separate functions. It was plus or minus the square root of x. Okay, so the composition of inverse functions. So we did not talk about this in Algebra 2. But if I find f of f inverse, I get x out. If I find f inverse of f of x, I also get x out. So this is just something that works for functions that are inverses of each other. So it says show that f and g are inverses of each other. So if I do f of g of x, I'm going to do f of x plus 5 over 2. So I'm going to take that x plus 5 over 2, and I'm going to replace the x with it. So I'm going to have 2 times x plus 5 over 2 minus 5. And as we simplified, you guys see the 2's will cancel. It's like 2 over 1, so the 2's cancel. So I get x plus 5 minus 5, which is x. Okay? So if that happens, if it simplifies down, like f of g of x simplifies down just to plain x, that means they're inverses of each other. And you can do it in either direction. So you can do g of f of x. So if I take my 2x minus 5, and I replace my x with it, I'm going to have 2x minus 5 plus 5, all divided by 2. My negative 5 and 5 go away, so I get 2x over 2, which is x. It worked that way as well. All right, so you've shown that they are inverses of each other. So if I ask you to show that they're inverses of each other, you can do either one. You don't have to do both. I don't think there's anything where it doesn't work for both. Maybe I should look that up. All right, so next one. So it says how to find the inverses of a 1-to-1 function, or an inverse of a 1-to-1 function. Okay, so for number 1, so we're going to find the inverse of the function. So we're going to switch our x and y's. That's our first step. So f of x was y. So I switch it and I make it an x. And my x value I make a y. All right, then I solve for y. So the first thing I'm going to do is I'm going to multiply that 4 over. Then I'm going to subtract the 3. And I'm going to divide by 2. So I get y equals 4x minus 3 over 2. Okay. So if I had f of x originally, the way I want to notate this is f inverse of x. So I'm going to say f inverse of x equals 4x minus 3 over 2. Okay. So if you go on to like AP Calculus, or if you take the SAT, maybe there's like multiple choice on it. You could have different forms. So always kind of keep an eye out for different forms. This could also look like 2x minus 3 over 2, or 1.5, right? Does that make sense? So you could bring the 2 into both pieces. So there can be other ways that you can write things. You don't have to write that. I'm just kind of keeping you aware of that. So that's our answer. So this next one, so our f of x is y, so I switch my x and y's, and I want to solve for y. Yeah.
What does it mean by check for domain issues?
I guess we'll get to some soon. Do I have any domain issues with this f inverse? No, because there's nothing that's like affecting the domain, right? Okay, so we'll have some that have like restricted domains. So it has to do with the plus or minus type of situation.
Oh.
Yeah. All right, so I'm going to cube both sides, so I get x cubed. If I subtract the 1 over, I get x cubed minus 1 equals negative 4y. So I'm going to divide by negative 4. So I get x cubed minus 1 over negative 4 equals y. So that's my f inverse of x. Okay. if this was a multiple choice question, we probably wouldn't leave it like that. What's kind of weird about the way we wrote this? The negative on the denominator, right? That's kind of weird. So what I would do is I would multiply by -1 over -1, so that it becomes 4 on the denominator. And the top becomes -x cubed plus 1. So if I have -x cubed plus 1, I'm going to write that as 1 minus x cubed. That's what f inverse of x is equal to. All right, and again, you could see that different ways. You could have the 4 brought into each thing and so on. So if you look at number 1 and 2, their domain and their range were both -infinity to infinity. There's nothing that's bad. Okay, so let's try some other ones. So number 3. So switch our x and y and solve for the new y. Okay, this one's not super hard. You could distribute the 2/3 first if you want to. It doesn't matter. Or you can get rid of the 2/3 by multiplying by what? Yeah, 3 over 2, the reciprocal, right? So I'm going to multiply by 3 over 2 on the other side. So I have 3 over 2x equals 7 minus y. And then I subtract my 7 over, so I have 3 over 2x minus 7 equals -y. And I want to get rid of that negative, so I'm going to divide by negative or multiply by -1 on both sides. So I get -3 over 2x plus 7 equals y. So that's our f inverse of x. And that could look lots of different ways. You could have -3x plus 14 all over 2. You know, like you could have different things. Does that make sense how you could have that if I got like common denominators? All right, so number 4 is a tricky one. So number 4, we actually did in Algebra 2. You guys were not very comfortable with it in Algebra 2. You didn't like it very much. Okay, so let's see if you like it in pre-calc. Probably not. Okay, so we're going to switch our x's and y's. So in this case, I have 2 y's. So I have 5y minus 7 over 3y plus 5. Okay. So we need to get the y by itself. Well, which y? We have 2 y's, right? Do you guys remember how to do this? Okay, so we're going to multiply the 3y plus 5 over. So I'm going to have x times 3y plus 5 equals 5y minus 7. And I can go ahead and distribute and say 3xy plus 5x equals 5y minus 7. I hear a couple of your light bulb moments. I hear people going, oh, yeah. No light bulb on yet. Okay. What do you guys think? We're trying to get the y by itself. So we have 2 y's. So we want to get all the y's on one side. So it doesn't matter which side you get them on. I usually try to do the side with the least number of negatives, but it doesn't matter. So let's say I got things on the left. So if I do 3xy and I subtract out 5y, so I got these 2 y terms together by subtracting this over. In the same step, I'm going to add or subtract the 5x over, right? So I'm going to have the -7 from before, and then minus that 5x. Okay, so I just took anything that had a y and get them on the same side, so get them together. So what that does for us is it allows us to pull out the GCF of y. So we can pull out that y. And then we can divide by the entire 3x minus 5. So we get y equals, so I'm going to say g inverse of x equals -7 minus 5x, all divided by 3x minus 5. Okay, so if you are doing a multiple choice test, they probably would not write it this way again. They probably do it in the way that has the least number of negatives. So some of you guys might have done this problem, and instead of getting the y's on the left-hand side, you might have subtracted the 3xy to the right-hand side to get the y's together. Does everybody see that over here? Okay, that would give you a different answer, but they're actually equivalent. So if I multiply by -1 on the top and the bottom, I could also have g inverse of x equals 7 plus 5x over, it would be like -3x plus 5, so I would write 5 minus 3x like that. So you might check, if you're like checking your answers with your friends and you're like like Lucy and Lily are working together at home and they're like, I got this, no, I got this, and they can't figure out who's wrong. Just multiply by -1 over -1 and see if they're the same. Okay? All right, so it says question. When you graph each of these, the new function looks like the previous function, only it's been reflected over the line y equals x. But what if we had y equals x squared minus 1? So do we all know with our transformations what x squared minus 1 looks like? So we're going to shift down 1. So we're going to have 1 comma 3, or no, 2 comma 3 and -2 comma 3. So it looks like this. So if I take every single point and I reflect it over that line y equals x, that point that I had at 0 comma 1 is now going to be at 1 comma 0. Hang on, 0 comma -1. It's going to be at -1 comma 0, right? And then I had 1, 0, so I'm going to have 0, 1. And I had -1, 0, so I'm going to have 0, -1. I had 2 comma 3, so I'm going to have 3 comma 2. And 3 comma -2. So here's what we get. So is the inverse a function? Right. So it's not a function. And you could try to do all those steps, but somewhere you're going to have like a plus or minus. So you're going to have a plus or minus square root of x somewhere in that if you try to find the inverse. Okay, so we need to do something called restricting the domain. And you guys kind of touched on this a little bit in Algebra 2, but we didn't do a ton with it. So what we do is we pick one of the sides. So if I pick only the right side of the original parabola, then that's going to be the same as only the top of the other parabola. So it's going to be this part here. Okay, so let's think about their domain and range. So if I pick only the right side, my domain is all the x values that are positive. X is greater than 0. So that means it should have a range when we flip it where all the y values are greater than 0. Right, when you switch all the x's and y's. Does that make sense? So let's do that on these. So it says find the inverses of the following functions and list the restricted domain if necessary. So it says hint, if you find the range of the original function, it will be the domain of the inverse. Okay, so as we try to switch our x and y, so our first steps are going to be the same. So already try it along with me. So switch your x's and y's. And we're going to solve for the y value. So I'm going to add the 5 over. What's my next step? So I end up getting y equals x plus 5 squared added to 4, which is a parabola. But our original function was a square root function. And square root functions, if you remember their parent function, it's like something like that. The parent function is like that, square root of x. Okay, but then when we found its inverse, we all of a sudden have this parabola. So something's wrong. Okay, we only need half of that parabola. So we're going to look at the original function's range. Okay, and this is tricky for some. So range is all the possible things we can get out. If I take the square root of a number, what's the smallest number that I can get when I take a square root?
0.
0, right? Square root of 0. I can't get a negative out. Do you guys see? So what's the smallest thing that I can get here? 0. Minus 5? Negative 5. Does that make sense? So basically, because of this square root, the smallest that I can have there is 0. And then I have the minus 5. So my range is everything from -5 on, -5 to infinity. So our restricted domain then, same thing. It should be that. So your final answer is going to have the parabola, but you're also going to list its restricted domain. Okay, so let me show you what's happening here. I think that's best if I graph it. Okay, so this first one, if I have square root, whoops. Okay, you should know what these look like with transformations anyway, but some of you guys are just, it's Monday morning and you look like you're gonna die, so I'm gonna do this on Desmos for you. Okay, here's what we have. Oops, let me hide this. Okay, the first one is the one that's in red. Okay, this is half of a parabola, okay, on its side, right? This is a square root function. It's been shifted, right? It was right 4 down 5. So from here we went to the right 4 and we went down 5 and we started the square root function. Does that make sense? Okay, its domain is starting at 4 and going to infinity. Its range starts at -5 and goes to infinity. Okay. This one currently has a domain, so the blue one has a domain of -infinity to infinity. That's bad. We want our domain and range to be opposite each other. Okay, so we have to pick one of these sides. So we say, oh, well, this domain, can I write on this? We'll see. This domain was, what did I say? 4 to infinity, and its range was -5 to infinity. We want this domain to be the original's range, and the range to be the original domain. So I'm not making it that complicated. I'm telling you to only look at the original range and write that for your new domain. Okay, Bill, you with me? So which side do I need if I want from -5 to infinity? I want starting here and going on this side. Maybe I should use red. I only want that side. I'm restricting it and saying I'm only taking the right side of the parabola. Does that make sense? Do you guys understand what I'm doing? Okay. Okay, so number 3. So same idea, but now I have an x squared. Yeah.
So is it gonna be the restricted domain? Is it always gonna be the range, the original range?
Mm-hmm.
Okay.
Yep. All right, so this one is a little bit different. Now we have the parabola, but I'm telling you which side of the parabola we have. So if I was sketching this out, 1, 2, 3, 4, it would be y equals x squared, only shifted up 4. But this is telling me that I have x values that are less than or equal to 0. So do I have the right side of the curve or the left side of the curve? The left side. I have this side right here. What's its range? Four to infinity, right? Y values. All right, so when I do my switching my x and y's, I had y equals x squared plus 4 originally. I'm going to switch my x squareds and y, or my x and my y's. I'm going to solve for y. So what happens when you start with a parabola is that you take the square root eventually, and you have to pick, oops, I wrote the plus or minus on one of the sides. I'm going to write it on the other side. You have to pick which one's right. So we have f inverse equals, and we have to pick between the plus or minus. So right now we have plus or minus the square root of x minus 4. So our original domain was x values less than 0. Oops. So it's -infinity to 0. We want our new domain and range to be flipped. So we want our new range to be -infinity to 0, and our new domain to be 4 to infinity. Now the domain here isn't what we're concerned about, because it has to be bigger than 4, because we have a square root, right? Does it make sense? Can I pick anything that's smaller than 4 in the first place? No, so it's not really the restricted domain that I'm worried about here, because that would be the domain anyway. I'm worried about this, the plus or minus. So which one's going to give me the range that I want? The negative one. So let's circle the negative, and that's the one we go with. Do you guys understand why it's negative? Because our range was negative values. And you can write its restricted domain, but it would have been its domain anyway when you do the square root ones. Okay, is this making sense? I know this is a lot. All right,